are there. Here I've got an ADW 535. You can see both the alarm and the fault light keeps going on. Even if it's not connected at the moment, you see there's absolutely nothing connected on that side. So it's already an alarm, so the fault. So I've connected up the Ethernet, and let's see what the software says. Okay, so immediately I have done a test on sensing tube 1. I should have, so double check. Yes, I should have error on sensing tube 1 because it's been disconnected. And I'm going to ignore any faults on sensing tube 2 for now. Let's just minimize that. So on this side, you will see I've got about 0.7 millibar, which is far correct because I've got absolutely nothing connected to that channel. But on sensing tube 2, I've got max alarm, and look at this. I've got 2375 millibar. This is absolutely ridiculous. This just can't be. There's definitely an issue with the hardware inside. If you take that and you compare this against my ambient millibar, which is just 1 bar at sea level, that is very close to this. But that is on channel 2 or sensing tube 2, that's completely out. So what will we do about this? Just to give you an idea how I'm testing this, I've taken normal ASD tube and I've 3D printed 2 ends. Both of them got M8 threading inside, but it's not all the way through. So in this side I actually did the same, did the same, and I just drilled a 3mm hole in the center and added this connector. So this is airtight. I've actually tested it underwater to make sure that it's absolutely airtight. The measurements for this I'll put on the comments below, and it works fine. I'll show you in the configuration the settings as well. It's equal to stainless steel of 13 meter with a sampling tube length of zoom. This tube length of a meter. Okay, so I will connect it up onto. I've got an external unit here, so basically the one right down there, if I can zoom in here, that unit I think is faulty, and it actually ties into this module on top. So what we will do is power down first. I'll take that out. We'll take that socket out. If it only comes out. Okay. So now I will take this unit, plug it in there, and take this unit and plug it in there. Make sure there's no shorting. Leave that unit down there. Just to show you the setup now. At the moment, I've got my sampling point or sampling tube, which is equal to a 13 meter stainless steel tube with my polymer tube on the side. Okay, and it's connected onto the secondary channel at the moment. So let's power it back up. Give it some time to start up and go back to the software. You should see that one start to react now. So you can hear the unit run as well. This first channel is running now. That's the second channel starting up. And let's see what the software says. Okay, so because we started up, we need to relink again. Connected. Okay, it's still starting up. By means of these two buttons, it's def not ready and max not ready. So let's give it some time, and that looks better. So we've got the 0.1 and we've got the minus 0.1. They're still setting if you look at these blue checks stuff. But immediately it looks a lot better. Okay. Got tube 1 fault. Just give it a few minutes, see what happens with tube 2 or channel 2 or sensing tube 2, yeah? Okay, it stays at 0 at the moment. What I'm going to do is do initial reset on that channel. Before I do that, just go back, parameters. Ignore how this thing is set up. It's been set up for extreme temperatures. And we've been playing around as well to test a couple of things. But what I wanted to see is sensing tube length for this red sampling tube I've made up is a 13-meter tube length with your supply line of 1 meter. Okay, so if you want to make it work, that's the settings you need to do to get it to work or to calibrate on this pipe. Like I said, I'll put in the comments below, I'll put the measurements for this. So let's go back to live graphics, initial reset, venting. Okay, so the venting procedure, I've disconnected this, so the sampling tube is loose. Let's give it a few seconds. I give it about 30 to 45 seconds, although the software says give it about 60 seconds. You would have seen that this tube is actually extended all the way out. So it just tries to get all the air out. Okay, so now we're gonna tighten that screw. So it's properly tight. Should be sealed. And we're gonna do the initial reset. So it's doing the compression. Initial reset. While it's doing that, let's go turn here. You see this curve going up. Now, from experience, I've realized that should this line go below the curve, there's actually still a leak. Okay, and it's -4 here, so there might still be a leak. I don't think I've properly closed that screw down with a nut. In this case, I know that the pipe is closed, so this might be still leaking there. The problem I've got on this one, I've got a stainless steel orifice on this side with brass on that side. It should be brass on brass actually. We don't have brass in stock at the moment. Let's just see what it comes out with. So I didn't go too low with the line. Let's see if it jumps back up. So it goes all very nice to 45.1. And let's see at the bottom if there's a fault coming up. You still see initial reset happening here. Max, not really, and definitely. So I'm waiting for that to go out. There it goes out, and you look at the fault at the bottom, it's cleared. Okay, so we found the fault on this one. So what I'll do now is I'll rebuild this unit in here. But it means we need to take off everything on top and dive down to what's below this. So that's my next job. I'll bring you back after that. I'm going to show you. I've got the main board removed now. So we basically have the channel 1 press unit or pump here and channel 2, and on here some electronics that actually measures the pressure inside here, and that is fault. I'm not going to try to change that. I'm actually going to take this entire part out by removing those two screws and the nut in front. There's a nut. Where's the light? We've got some light. That nut in front. We'll take it out, put a new O-ring in there, seal it, and fasten it back down. Right, I've got a new pump in. I just powered it up now, so it's going through cycles. You should see it. Channel 2 there, it starts up again on channel 2, or yeah, pipe 2. So let's go back to software and let's recalibrate. I still have this loose, so I need to vent it quickly and then we'll do the initial reset. So I will be closing this one now. Zoom as I. Okay, so that's closed back up. It shows. Don't know if this is helping a lot. Let's do this right off. Okay, it shows 002, which means it's resetting line 2. So I'm going back to the software. Zoom, come on, there it's nice. Okay, so I'm going back to the software, and then I'm going to tell it to initial reset and try to complete it. And I'm keeping my eye on the graph. Like I said previously, if this goes back below zero, or quite a bit below zero, then you know there's still a leak on your pipes. Yeah. You need to get used to this graph, this format. It's very important. Depending on the pipe lengths, you will realize longer pipe lengths will have a lower graph length, but also setting your thresholds on your graphic will determine this. We're going back to so 0.2, which is still nice. It's not deflecting a lot. Going slightly more negative. Now we must pressure again, so it's go up again here. Stays positive. Let's see if it stays constant. This is where it's actually testing now if the pipe is leaking or not. So it stays quite constant at the moment. Just note, if we talk about leak, we're talking about less than a millibar per 24 hours. That's how sensitive it is. In all my testing, trying to make up this sampling tube, I figured out if you lose less than a millibar in 24 hours, the sensing tube, the sensing module will pick it up. And I've had guys on site saying, but my tubes are fine, they're not leaking. We had a compressor on him for 24 hours with a gauge. A 1 bar gauge will not show you the leakage over 24 hours. That's how sensitive this is. You really need to make sure there's absolutely no leakage. Right, so our initial reset is gone and it seems to be happy. Now what I'm going to do just to return this, to check something is you can read the initial reset data back. And what I'm looking for is, this is a supply line length is 1 meter. The monitored parameterized is what we've set it. We've set it to 13 meters and the monitor length determined is 13.3 meters. So it's basically very close to spot on to what we've got. This volume was calculated and again, it's somewhere down in the comments below. Just to show you how sensitive it is, I'm placing my hand on the tube here to heat the tube up. And just by means of detecting the tube heat and the expansion of the air inside the tube, we are getting an increase in the millibar. This also tells me that our system is starting to work correctly. So I can rub the tube, heat it up quite nicely. It's actually easier to heat this tube up than the stainless steel tube. So the hotter I'm making it, or the more I rub it, it actually gets nice and warm. And oops, I forgot it. And we get a nice increase in temperature in millibars. I'm going to leave it to cool down and it should come down again. You can also see the reaction and the pressure difference here. It's extremely sensitive, this unit. On this setting, we can see it's about 900 to reach max alarm. We're only 51 now. The reason for this is this unit is installed in a environment where it measures 200 degrees Celsius with 400 degrees in fire alarm. So this actually goes up in normal operation up to about roughly 500 to 600 millibar, and then ambient temperature when everything is switched off coming back to 50, and when it's going into fire it goes up to, when it reaches 900 millibar it will go into fire, which is quite a lot. So it starts to come back down as the temperature of the tube is getting back to normal. You can see the millibar per minute is decreasing as well, so it's coming down. Close it up. I can see the room temperature at the moment is 28.3. So it's look main board is 28.3. Yeah, so it is quite hot here at the moment. So that's very close. So I'm going to check my other equipment. Yeah, we're at about 26, 27 degrees Celsius, 28. And this is at just before 9 in the evening. Okay, so it's coming down, it's still decreasing, which is nice. And that's it. Just to go through this quickly, they will see, I don't know how many of you know this product. We've got the parameters. Like I said, these normally you export it from the programming software, and then you import it here. I'll make another video with all the parameters, all the settings, just it's a detail of it. For this application, we've turned some of them off because they actually do not work. Trying to resolve issues. Relays, we can set all the different relays. We don't have extra boards on here, so basically we're just working on the main board events. Settings, same fault clock activated, general latching. So general latching is any latching that will happen. You can switch any latching on and off. Because this unit doesn't have a reset button in front, we just keep all the latching disabled. On the same on the parameters, we'll make sure there's no all the latchings are off. Otherwise, it becomes a problem to reset once you're done. Okay, this is on because but the state is off, so they will never engage. Networking. Okay. You can download firmware. We've done the time just now again, so we can synchronize, update the time. You can isolate the unit, read statistical data. For this, as far as remember, reads. So we've been working on the tube, so I'm ignoring anything that side. So basically the maximum that we've had till now, the minimum. This screen is also important for if you do stuff that's out of the EN norm, like we've done with this project. It's completely out of the EN specification. The temperature range is from anything from 12 degrees Celsius all the way up to 200 degrees Celsius. Then when it goes into fire inside the equipment, it's about 400 degrees Celsius. That's outside the normal EN specifications. You can't detect that. So then we use this to get the maximum and minimum settings. And based on this, we will make the final adjustments. Like I've said, I'll make another video on all the settings and what to look out for. I hope you enjoyed this video. Leave a comment below. Thank you very much. Good night. Hello to Jen. Thank you very much. Good night.